Okay, so if you remember, we talked about roots on the bottom like a tree, exponent at the top, right? So that gives you all your pieces, and you just need to put them in. The root goes right here. You don't actually have to write the square root, because that's the one we know is always there, right? But you can, since it's good to have it, to put that number in. Oops, not 5. And then this is raised to the 5th, and then you throw your base in there. What was the base? X. And then you have to come up with a possible base that will make this work. So what do we know it has to be able to be, we have to be able to do to it? Yeah. Yeah, because the first thing that would happen to any number we plug in there would be a square root. So it has to be a number that's square rootable, and then when you take it to the 5th, it'll stay a nice number. So give me a number that's square rootable. What do you think? A number that is square rootable. 25. 4 would have worked as well. All right, let's do 25. Right? So basically we're saying x equals 25, right? Now if you plug that in, well, square root of 25 to the 5th, which would be, and this was like on your homework, now you have to evaluate the inside, then the outside. So square root of 25 is 5, so that's 5 to the 5th. Ooh, what's 5 to the 5th? I don't even think I have enough room here.
3,125.
What is it?
3,125.
Okay. I do have enough room. Okay. Cool. All right. Does that make sense? All right. Next one. Okay. Again, exponent root. So 3 and 4. Set up your radical. Put in your pieces. So my root is the 4th root. My base is x, and it's being raised to the 3rd. So now if I'm going to come up with a possible number for x here, I have to pick a number that I could do what to? I could take the what of? The 4th root of, right? So it has to be a number that is something to the 4th. So anybody come up with something? 16, okay. So 16, so let's see if that works. The 4th root of 16 to the 3rd. What is the 4th root of 16? 2, right? Because 2 times 2 times 2 times 2 is 16. So that's 2 to the 3rd, which is 8. So that worked. That got us a nice clean number. Make sense how we're doing this? Okay. All right. Y to the 1/3. What's my root? What's my exponent? 1. Okay, so then I set up my radical. I put a little 3 in there, and then I raise it to the 1. I mean, you could, but what do we know anything to the 1/3 is? That's one of the first things we learned, right? To the 1 over something is just that root. So we can just say the 3rd root of y. And then to find a y that works for that, we just need a y that is 3rd rootable, right? Something that is something to the 3rd. So what number do we want to go with? 729. Okay. So if I take the 3rd root of 729, what do I get? 9, right? So that works. So that is a good number. All right, last one. Exponent is 4. Root is 5. So I have the 5th root of y to the 4th, and I need a y. What must be true about this y? You must be able to take the 5th root of it. So, boy, I don't really know the things that you could take the 5th root of. So what could I do to figure one out? Yeah, just take something to the 5th or multiply a number 5 times. Yeah. We did say we're not going to use 1. So what number could work here? 32. We already did one with a base of 2, though. Well, 125 would be something to the 3rd. Yeah.
32,760.
Okay. 32,768. Okay. So let's see if that works. The fifth root of 32,768 to the fourth. What is that? The fifth. What is the fifth? First of all, what's the fifth root of that giant number? 8. Okay. Now 8 to the fourth is what? What do we think? 4,096, which is a nice clean number. So that worked. Okay? All right. So this is basically just getting you used to converting to the forms, then evaluating, right? Kind of in a backwards way. Okay. So let's go and see if we have any questions on the homework. If we don't, that's okay. Today's lesson is kind of like, okay, the reason we spend a lot of time on properties, the reason we spend a day on fractions, everything kind of smushed in together, okay? Because now we have this thing right here, and we're going to dive right in, okay? We're going to apply properties with fractional exponents, okay? Now, when I have the same base and I'm multiplying, what do I do with the exponents? For instance, if I had x squared times x to the third, I would say, oh, that's what? X to the fifth, because I would go x to the 2 plus 3 in my head, which is x to the fifth, right? I just add the exponents because it's the same base, right? Keep the base, add the exponents. Same situation here, it's just going to get more complicated and you might not be able to do it in your head, but that's okay, all right? So if I have 4 to the 7/6 times 4 to the 4 thirds, well, I keep my base. What's my base? 4. And I add the exponents, and this is where it might be a little different because you're not going to be able to do this in your head probably. So you write it out like I did here. You say, okay, I know I got 7/6 plus 4 thirds. Okay? Just set it up. And then you say to yourself, I don't know if I can do that without working it out. So you take it out of the problem. You say, okay, I'm taking this part to the side, right? And I'm going to say, I'm going to ask myself, 7/6 plus 4 thirds. How do I add that? And that's when you get into your adding or subtracting fractions. We know when we add or subtract fractions, we need a what? Common denominator, and I see 6 and 3. So what's my move here? Make the 3 into a 6 by multiplying by 2. Bump this one up because it goes into that one, right? So I'd say, okay, times 2 over 2, that gives me 7/6 plus 8/6, which is 15/6, okay? Before I plug it back in, I'm going to see if I can reduce it. I always check that because these are important numbers. Like one of these is a root, one of these is an exponent. I don't want to have to take the 6th root if I don't have to. Okay, so what can I divide these both by? 3. So I'm going to divide by 3, and this turns out to be 5/2. So this goes back in where that was, right? We figured out what that is. We know what 7/6 plus 4 thirds is now. It is 5/2. So this is 4 to the 5/2, and now it becomes like your warm-up. Take the second root, take it to the 5th, okay? So I say, okay, square root of 4 to the 5th, which is 2 to the 5th, which is 32. Okay? So it turns out 4 to the 7/6 times 4 to the 4 thirds is 32. Okay? So that's your process. You have to apply the properties, then use your knowledge of adding, subtracting, multiplying fractions, and simplifying. Put it back in, and then evaluate. Okay? So I want you to try the next one. Okay? Question?
Could you do the root after?
This right here?
Yeah.
turned it into a square root. Second root is a square root, right? Okay, try that next one. So, second problem, okay? Think to yourself, well, what do I do when I have an exponent to an exponent? What happens? And then apply that to your fractions. If you're not sure where to start, I will remind you that x squared to the third is x to the 2 times 3, which is x to the 6, right? So that's the process. Now you have fractions.
Oh.
All right. So power to power, we what? Multiply, right? So I'm going to have 64 to the 1/2 times 4/3, right? If you need to take that over to the side, you can. For multiplying, sometimes you can just go across, right? And it's not as hard as adding and subtracting. So I'm just going to go down. 64 to the 4/6, right? Now, great example of why we want to check for simplification, right? Because if we went with this right now, I would have to take the 6th root of 64 and raise it to the 4th, which I can't do without my calculator, right? I don't know what the 6th root of 64 is, right? But if I recognize, 4 over 6, that reduces to what? 2/3. I can divide them both by 2. Well, now I have 64 to the 2/3, and I can take the 3rd root of 64, so I'm in business, okay? So this is the 3rd root of 64 squared. And the 3rd root of 64 is what?
4.
Very good. 4 squared is 16. You gave me the hard one. All right, so that means that 64 to the 1/2 to the 4/3 is 16, right? You can do some pretty crazy things here, right? All right, moving on. I'm going to do, this is when you would evaluate, but sometimes you're just applying the properties to simplify, and that's what we're going to do on the back. We'll do a problem with you, and then I'll let you work on some. Okay, so here we go. I have k to the 5/4 to the 1/2 times k to the 3/2. All right, same tips and tricks as before, right? If I see parentheses, I'm going to get rid of them before I do anything else, right? So that means I need to do k to the 5/4 times 1/2, right? Power to a power, okay? And I'll just bring this k to the 3/2 along for the ride for now. So if I do that, we multiply across, right? And I end up with k to the 5/8, right? Times k to the 3/2. Now it's kind of close to what we were doing on the front, right? When I have two bases that are the same and I'm multiplying, I do what with the exponents? Add them, right? Power to power is when I add times, right? So I always like with these, since they're not something you can do in your head, to write it out. Actually write it out as k to the 5/8 plus 3/2. And then if you need to, you take this over to the side or down or above or wherever you need to, and you figure it out. What is 5/8 plus 3/2? Well, I need common denominators. If I have 8 and 2, where can I go?
You can multiply the 2 by
Yeah,
4.
exactly. I'm going to make this one 8, and then I'll be in business. Okay, so I multiply by 4 over 4, and I have 5/8 plus 12/8, which is 17/8, right? And then that goes back here where that was, and my answer is k to the 17 eighths. And if it tells me, pay close attention to instructions, it might say, give me it in radical form, it might say, leave it in exponential form. In this case, it didn't say either. So we'll just leave it like that. But you got to remember how to do that if you need to. Okay? So try these other problems, right? When you get to the one below, I'll check back in, but you got to think about what do you wish it would look like to make it work for you, okay? All right, a couple different ways you could do this. I'm going to, let's go with our normal process where we clean up the top and then go up and down. Okay, so if I do the top, I got 6, and then I have k to the 2 plus 1/2, okay? You would take that over to the side, figure out what it is. And then on the bottom, I have 3k to the 1/3, okay? You end up with 6k to the, that's 4 halves plus 1/2, that's 5 halves, okay? And again, if you have to take that over to the side, you can, over 3k to the 1/3. Okay, 6 over 3 actually divides, so I end up with 2. And then I'd have k to the 5 halves minus 1/3, which you, again, would take over to the side to figure out. You can do that. 5 halves minus 1/3, 3 over 3, 2 over 2, right? Gives me 15/6 minus 2/6, which is 13/6. So this turns into 2k to the 13/6. Okay? Can't reduce that any further. All right. Now the next one had an extra wrinkle that I didn't tell you what to do. Some of you are on all over it. If I have this kind of situation, well, I got exponents, I got radicals, right? I don't know how to deal with radicals like this yet. So what can I do? What do I know I could change that to? The cube root of x can be restated as x to the 1/3, right? So I end up with x to the 4/3 times x to the 1/3 times x to the 1/2 over, and then I'll just do this part, right? This is x to the 4/6. Okay, let's clean this up a little bit. X to the 5/3 times x to the 1/2 over x to the 2/3. Now, normally I'd clean up the top, then go up and down. But I notice I got 5/3 on the top, 2/3 on the bottom, and those will subtract fairly easily, right? So I'm going to do that. I'll have x to the 5/3 minus 2/3 is 3/3 times x to the 1/2, or x to the 1 times x to the 1/2. And I just need to add those two, right? And that's 2 over 2, that's 1 over 2, and that's x to the 3 over 2. Now, every single adding of fractions and subtracting of fractions that I've done here, you can take to the side and do if you need to do that, okay? But that's how that's done, okay? And the last one, I'll help you set up. Now, again, I can't work with a radical and exponents at the same time. So what I'm going to do is I'm going to change this to whatever I see as a radical to its fractional exponent. What's the only radical I see here?
The only radical?
Yeah, it's a giant what? Square root, right? No, there's nothing there, so it's second.
Oh, yeah.
So that means this whole thing is being raised to the, not 2, 1/2. So m to the 0 over m squared times m squared is all being raised to the 1/2. And then that's being raised to the third. Okay? Now let's clean up the inside because we can make this a little easier on ourselves. M to the 0 is 1. M squared times m squared is m to the 4th. So then I have that to the 1/2 to the third. Okay? Now let's do this power to a power. So I have 1 over m to the 4th to the 3/2. Right? With me? And then I can apply this exponent to the bottom just like I can to the top. So this is 1 over m to the 12/2 because 4 over 1 multiplies across, power to a power, which is 1 over m to the 6. And I'm done. So roots and this was basically what we just did. If you have an exponent, can you make it a radical? If you have a radical, can you make it a fractional exponent, right? And then sometimes you're going to evaluate afterwards, sometimes you're not. So what problems on homework 4, if any, do we want to see? 13? Okay. 10? 10, 13, 17? Okay. All right. 10, well, hold on. 10, 13, 17. All right, good mixture here. All right, so 10 was where's 10? 10 was, well, for the skill that you really need is this. Can you change this to this, right? That's your root, that's your exponent. You know the places they go in the exponent fraction. Now, it says to use your calculator, though. So you would just put 4 to the 4/3 into your calculator and get a decimal value there, right? That's just practice for your calculator. Right, what is that? Anybody get it? 6.35. Right, that's all you had to do there. All right, 13. All right, so this was without your calculator, right? Okay, so you needed to be able to convert this to radical form, then evaluate, right? So again, it might be helpful to just say, to do what we did in the warm-up, even though it's not asking you to, just to get our pieces, right? What's our exponent? 2, and our root is 3, right? So I need to rewrite this in radical form. So I'll say, okay, third root of 8, and then that squared. And then I just think inside out. What is the third root of 8? Or what times itself 3 times gives you 8? 2. So this is really 2 squared, which is 4. So that's your process for any of those problems, okay? Find the root, then take it to the exponent. Okay? Last one was asking you, hey, are these equivalent? So you kind of had to do a little bit of different things that we've been doing, right? Over here, you needed to do what we just did, evaluate with a fractional exponent. Over here, you needed to use exponent properties. And you needed to find out, hey, are these the same number in the end? Okay? So we'll start with this one. Well, 16 to the 3/4, that's our exponent, that's our root. So I'm looking for the 4th root of 16 raised to the 3rd, right? The 4th root of 16 is, again, 2, right? So that's 2 to the 3rd, which is 8. So the value of this is 8, right? This one, well, I needed my properties, right? 2 to the 1 times 2 to the 2, well, that's 2 to the 3rd. And then on the bottom, I have 2 to the -1. Okay, so then quotient property says subtract, so that's 2 to the 3 minus -1, which is 2 to the 4th, right? Because it's minus minus, so you add. So it's 2 to the 4th, which is 16, which is not the same. So they're not equivalent. Okay, that was your process there. Okay, a little bit of everything. All right, homework number 5. Anybody need to go any of the fraction ones? I mean, adding fractions, subtracting fractions, multiplying fractions, or simplifying. 3 and number 9. Okay, so number 3, we don't have common or denominators, right? So we need to get them. When one doesn't go into the other, an easy thing to do is just multiply them by each other and get that common denominator. So I'm going to say, okay, I want them both to have 70 on the bottom. So I'm going to multiply this one by 10 over 10 and 7 over 7 over here, right? That'll give me 70 on the bottom of both, right? That gives me 60 70ths minus 21 70ths. You keep the bottom, you add or subtract the top. 60 minus 21 is 39, and you keep the bottom, so that's 39 70ths.
And you can't simplify it. I tried.
Yeah, it doesn't. There's nothing that goes into both. All right, next one was 9. Okay, so remember with fractions, when we multiply, we just multiply across, right? Straight across. So 5 times 7, 7 times 5. That's 35 over 35. Anything divided by itself is just 1. Anybody do it a different way? Well, what you can kind of do also is, since you're multiplying across, it becomes one big fraction that is 5 times 7 and 7 times 5. And anytime you have anything over itself, boom, 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 1, 1, so it's 1, right? Everything cancels. All right.